Hi guys, I'm Alessio, and in this video I'm gonna show you how to run the Polkadot Kubernetes monitor, a tool I've created, on your local machine. Let's begin. Our first task is to clone the GitHub repository. You can find the project link down below in the comments section. So now just follow the green button which contains the cloning URL of the project. We see here multiple choices. I recommend you to use the HTTPS method. We can copy this URL, open a terminal, and then type the git command clone. The project has been copied then in our local machine. Let's now go to meet the requirements of the project. So scroll down to the requirements section where we can find a list containing all the required tools. Let's focus on Docker and follow the related link. We can choose now the instructions related to our operating system, macOS in my case. Then click Download from Docker Hub. Let's follow the installation process, at the end of which we can verify that our Docker instance is running properly, as you can see here. Now is the turn of Kind, a local simulation environment for Kubernetes clusters. We can follow the relative link, follow the instructions that on macOS will simply collapse to the command brew install kind. Checking the version with this other command let us verify that kind has been correctly installed. Now it's the turn of Helmfile. Helmfile is a tool that allows you to configure and deploy Helm charts in a convenient and a simple way. We follow the link in the requirements section and follow the instructions for our operating system. As you can see here on macOS, you can just run the command brew install Helmfile. After a few seconds, we can verify the correct installation and we will have satisfied this requirement too. Now to the most interesting requirement, a Polkadot or Kusama running node to monitor. Using Polkadot Secure Validator, the official tool from Web3 Foundation, I easily deployed a testing node that I can ping. I can also access its metrics, which as you see are protected by authentication. I therefore try again, providing username and password, and finally I can get the metrics of the node. With this step, we are done with the requirements section. Now that we have met all the requirements, we can configure our application. The How to Configure section of the project describes the configuration files and their parameters. Opening the config folder of the project, you will find two template files. One related to the nodes to be monitored, the other related to the parameters of the monitoring system. Let's create duplicates and remove sample from their names. We start by configuring the node parameters. As you can see, the file is organized, so there is a separation between Polkadot and Kusama validators. In our test, we are focusing on a single Kusama node, so let's retrieve its IP address, the same pinged previously. Then the address of the stash account of the validator we want the monitoring system to think is tied to the node. In this case, I'm just placing the one of my personal Kusama validator. We then move on to configure the monitoring system. I'm gonna show you the minimum configuration, so I'm removing all the optional parameters. Let's then configure the HTTP authentication to the node, which is needed to extract the metrics. Let's retrieve the previously used command, just to be sure the username and the password match the configuration file. The last parameter we are setting is the Grafana password. The username will be admin by default. So the minimum configuration for a local deployment is now complete. Now let's get ready to start the deployment script. Let's go to the section how to deploy it locally and follow the instructions. So we need to run a bash script called deployLocal.sh that we can find in the scripts folder of our local project. As you can see, a Kubernetes kind cluster is being created on our local machine, and a series of Helm charts is being deployed to it. We can finally verify the success of this operation by running the command kubectl get pods. You should expect an outcome similar to this one. Now that our local cluster has been successfully deployed, we can access the monitoring interface, Grafana. We should check that Grafana is up and running in the cluster and then do a port forwarding operation of this pod on the default port 3000. This service is now accessible from the browser at the localhost address. If everything worked correctly, we should be in front of the Grafana interface now. The username is admin, while the password is the one we previously configured. Once inside, we can go directly to the dashboard section, where we will find some dashboards loaded by default. Let's focus on the node exporter dashboard. Here we can see that our monitoring system is already collecting data related to the metrics of our node, which as you can see correspond to the IP address previously set. Another interesting dashboard is the one related to the node synchronization information. For instance, you can see that the node we are considering has been started recently for testing purposes, since the current best and finalized blocks are far away from the sync target. Thank you guys for watching. I hope you enjoyed the tutorial. Please feel free to contribute by leaving a comment below or by opening an issue in the GitHub repository. Bye.